All right, so this example problem will probably feel a little bit circular as far as like, the direction we're going to go. I'm going to really try to highlight exactly out how we're going to take this path, and then how we're going to solve this problem, and then solve it out for you. All right, so what we're being asked to do is a zero point 0.1, so 0.10 molarity of hydrochloric acid, so that would be HCl. Acid solution has hydronium ion concentration of 1.0 times 10 to the negative 1 molarity, moles per liter. All right, so let's see. 1.0 times 10 to the negative 1 moles per liter. Calculate the pH. Calculate the pOH. And the hydroxide ion concentration. So hydroxide, OH, negative 1, ion concentration. So I'll just put brackets around there to signify that it's a concentration. Now, we know there's a few equations that we can write down. One of them is that the pH is equal to the negative log of the hydronium concentration. And so when you're asking me to do this, that's pretty straightforward. We know also that we can convert this to, well, this equation is actually the same thing as this equation over here. It's hydronium concentration, H3O plus, is equal to 10 to the negative pH power. These are the same things. That's what the log means. It's taking that this answer and raising it to the power of whatever the log is at, and that's going to equal your hydronium concentration. So we also have an equation for pOH, and that would be pOH is equal to the negative log of the hydroxide concentration, OH negative. Which we can get this equation that the hydroxide concentration is equal to 10 to the negative pOH. I mean, essentially these equations are the same thing. And the last equation that we have is we know that this scale goes from 0 to 14. So, so if I add up whatever my pH is plus my pOH, then what's that is going to equal to is 14. All right? So armed with all of this knowledge, we're going to be able to solve this equation out. I'll tell you what, we already know how to get the pH. That's pretty straightforward. That's using this equation right here. I'm going to change colors so that way we can color code this thing. To get the pOH, we're going to use this equation right here. And then to get the hydroxide concentration, we're going to use this equation right here. All right, so let's work in black first. The pH is simply the negative log of 1.0 times 10 to the negative 1 moles per liter. Plug that into your calculator and you simply get 1. Yeah, that's it. It's just 1. Okay, so the pH is 1, and that means that the pOH, so we'll work in red now. So the pOH plus the pH is equal to 14. And I know that the pH is 1, so pOH plus 1 is equal to 14. So the pOH is equal to 13. All right, good. So I have the pOH. Now from that, I can use this other equation right here to say, all right, well, if my pOH is 13, then my hydroxide ion concentration is 10 to the negative 13.00. So that would just simply be 1 times 10 to the negative 13 molarity. And so those are my three answers. Let's just do a different color altogether. It's pH is 1, POH is 13, and hydroxide concentration is 1 times 10 to the negative 13.